everyone. Today we are talking about data structures. So first, what is data structure? A data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. So a data structure is not only used for organizing data, it is also used for processing, retrieving, and storing data. There are different basic and advanced types of data structures that are used in almost every program or software system that has been developed. So we must have good knowledge about data structures. So in this picture, it shows some commonly used data structures, and this is a classification of data structure. And the graph itself is a kind of data structure called a tree, which we will talk about maybe later. So you can see that data structures are mainly classified into two types that are linear data structure and nonlinear data structure. So for linear data structure, data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent elements. So for this type of data structure, it is called a linear data structure. So examples of linear data structures are array, stack, queue, and linked list, and etc. So for static data structure, they have a fixed memory size. It is easier to access the elements in a static data structure. An example of this data is an array, because when you declare an array, you must first assign a fixed memory size to it. So another type of linear data structure is called dynamic data structure. So in dynamic data structure, the size is not fixed. It can be randomly updated during the runtime, which may be considered efficient concerning the memory complexity of this code. So examples of this data structure are queue and stack. And next we'll talk about nonlinear data structure. So for these kind of data structures, data elements are not placed sequentially or linearly, and in a nonlinear data structure, we can traverse all the elements in a single run only. So trees and graphs are typical nonlinear data structures. So when traversing these kind of data structures, we'll implement special algorithms to finish the job. So we cannot simply, for example, use a for loop to traverse the whole data structure. So why do we need these data structures? So the structure of the data and the synthesis of the algorithm are related to each other. Data representation must be easy to understand, so the developer as well as the user can make an efficient implementation of the operation. Data structures provide an easy way of organizing, retrieving, managing, and storing data. So here is a list of the needs for data. For example, data structure modification is easy and it requires less time, and it saves storage memory space. And data representation is easy, and it is also easy to access to the large database. So in conclusion, I think that the data structure is mainly very convenient and easy for the users or programmers to organize your code and process the data that you have. So now we will introduce a very simple type of data structure, that is array. So first we'll also introduce what is an array. So an array is a linear data structure and it is a collection of items stored at contiguous memory locations. The idea is to store multiple items of the same type together in one place. It allows the processing of a large amount of data in a relatively short period. The first element of the array is indexed by a subscript of 0. So that means that the index of the array starts from 0. And for example, if you have if you have like 7 elements in the array, the index will be from 0 to 6. Okay, so there are different operations possible in an array, like searching, sorting, inserting, traversing, reversing, and deleting. So here we'll introduce the characteristics of an array. So an array has various characteristics which are as follows. Arrays use an index-based data structure which helps to identify each of the elements in an array easily using the index. If a user wants to store multiple values of the same data type, then the array can be utilized efficiently. So it is very difficult to store different types of data in a single array. So commonly people just, for example, store a lot of, for example, ints or maybe a lot of string type variables together in an array. So an array can also handle complex data structures by sorting data in a 2-dimensional array. An array is also used to implement other data structures such as stacks, cubes, heaps, hash tables, etc. So these are also the data structures that we will talk about later. And the search process in an array can be done very easily because the array is a very linear data structure. So you can just search the array utilizing its index. Now we'll talk about how to declare or create an array in Java. So we use a variable to represent the array as a whole. So here is an example of declaring an array variable in Java. So first, you declare the type of the array. For example, it is int type here. Then use square braces to tell Java that the variable that you declare is a array type. The square braces are put here. Then you put a single space here. Then you can tell Java the name of the array. For example, it is called grade here. So you can know that the array here is created to store for example, the grades of all the students in the class. And then it can not create the array by simply declaring the array variable. So what you should do is to create an array here. So you should write grades equal to new int 8. This means that you create 8 elements that are int type variables in your array. So by combining these two, you can create a new array in this form. So you put int, then square braces, then space, then grades, then you give 8 int type variable elements in it. So it has 8 int type elements here. So at first, Java will initialize the array by assigning 0 to all the elements in the array, but you can also create the array if you want to initialize it by yourself. So you just use curly braces to include all the initial elements of that are inside the array in it, and then assign it to it. Okay, so here is the definition of getting the information of the length of the array here. So the length of the array is the number of elements in the array. So the length of an array can be obtained as follows. First you put the name of the array here. Then you add a dot here, and then you type length. So here is an example. If you want to access the length of the array called grades that we declared before, so you can just type grades.length. So this will give you the length of the grades array. So you should know that the grades.length is not a method. So you should not add the braces here after the length. So you just simply put the grades.length here, and it will return an int type answer that is the length of the array here. So next we'll talk about how to access an array element. So we can use the expression of the form array, then square braces, then inside these square braces you can put the index of the array there. So here is an example. For example, the grade 0 accesses the first element, and grade 1 accesses the second element. So grade 5 accesses the sixth element.
And now I will talk about how to traverse the whole array. So basically we just start from the first element in the array, which is at index 0, and increment the position by 1 each time, and until we get to the final element inside the array. So you can look at the code here. So first we use a for loop. So inside the for loop we start the counter I from 0 until I is smaller than grades.length, because actually the array grades starts with 0, not 1. So actually the final index of the array is the length of the array grades minus 1. So then we increment I by 1 each time, and then we can do the operation of each of the elements inside the array we want inside the curly braces of the for loop. So this time we just print the grade out. And finally, we'll talk about the applications of array. So basically, it is used to store data. So it can be used in solving matrix problems, and database records are also implemented by an array. It also helps in implementing a sorting algorithm. So it is also used to implement other data structures like stacks, queues, heaps, hash tables, etc. So these are also data structures that we will talk about in the following club activities, although perhaps these are also commonly implemented using a linked list, so which we will talk about next time perhaps. And here we'll talk about some real-life applications. So it is frequently used to store data for mathematical computations, so this is very easy to understand. So it is also used in image processing, and the book pages are also real-life examples of an array.